Can you hear me at home? Can you hear me? We're here.
I can hear you.
Yes.
Excellent. All
Yes.
right. Close this. I don't think I need that. You're still up. You're there. Everything's good. It's recording. Let's talk about what's going on. What is going on is you have a test on Friday. It's a big test. It's the midterm. And it's a lot like the last test, except has more questions. Okay. There will be whatever 8 questions you have to answer in the beginning. That you just 4 will be vocabulary and 4 will be read this. And then there will be 4 questions that are like multiple choice. This test, though, is exactly what I told you. It's not multiple choice. It's not like only one thing. There could be it's like pick all that apply. Definitely on this test. I told you it was going to be on last test, but it wasn't. This test, it is. You want that because you get partial credit. If it's just one answer, you don't get any credit. One thing you'll do is you'll get some credit for getting one of them right. But the point is you can't, yeah, it's a little trickier, but I give more part credit. I find that for the midterm and the final, these generate more part credit than the last test. The last test was just right or wrong. But I don't look at that because that's reading comprehension. I don't know. I don't know why you pick what you pick, but you pick it. Then I only look at the next group if you get it wrong and I can find anything on Desmos. I look for the Desmos. Okay. And then the last one, I watch the end for your presentation. I listen to what you say. So you have to find the answer. You can type in the answer. I don't care what you do. In the end, you're going to present it. I have to tell you some things, though. Just again, back to the idea of this test being like an interview. The first questions I listened for, I don't think you understand that I'm sitting there listening and waiting. I have nothing better to do with my life than wait for you to answer the question. But I'm not a patient person. If you take too long, I start looking and it's like, what the hell? Why did this problem take so long? And then I get impatient and then I start taking off points. And then all that I'm thinking in my head is how many points can I take off? That's fair. What?
I got a question.
Yes.
So
here.
you just uploaded the quiz number 7?
No, it's been there the whole time.
I didn't see it this whole time this week. I checked it multiple times.
I just uploaded it. Yes, but you have, I'm sorry, someone should have told me it wasn't there. I uploaded it from my other class. I forgot for you. But it's not just a quiz 7, it's there. I can give you more time on it. I don't care. But the problem is this: you have another assignment due on Thursday, a big assignment. It's called, and it's not there either because no one reminded me. It's in my online class, has it. It's called a practice midterm. And guess what? It's the midterm I gave last semester. So it's not just a practice midterm, it's the actual midterm that I gave last semester, but you're not getting that midterm. So since I'm not giving that midterm to you, I figured I would just let you have it as a practice. You get one shot at it. It has to be graded by me. And it's one right or wrong. I don't have time to grade. I'm going to be grading your midterms too. And since you make me sit there and wait for you to get answers, it's going to eat up too much time. This one is more like this one. You just put the answers in the box and they're either right or wrong. And I will grade them and then I will give you back the point. They're only worth, it's 15 questions, 1 point a question. Actually, not even. I think there's 20 questions and you get 3/4 of a point a question, whatever. Whatever it is, right or wrong, I can't give you part credit for it. It's not worth that much. It's the point of this practice test is for you to practice taking a test. Do not start it and stop and say, oh, I'm going to get something to eat and come back later. It's timed. It's meant to be taken like a test. It has all the annoying things of a test, but without, and it'll give you an idea of what I asked last year. Okay? Well, not last year, even just this is last summer. a few months ago. So I think it's a good thing. I want it done by Thursday because that's what I'm gonna go over on Thursday for sure. Today, I'm gonna go over something else, but on Thursday, I'm gonna go over that. And I will only go over the questions that you did badly on, so be sure you go on there and do badly on them, so I go over them, or do well on them.
I have a question.
What?
So the practice answer is, even though it's technically like on a shadowing of our actual midterm, when we take it, it's essentially like a quiz, like we don't have to.
It's
go-
counting like a quiz.
Yeah, so we don't have to go through the process of talking,
No talking.
just to.
Nope, just do it. Just write the answer, write the answers in. It might say it, but it won't. Those ones are, I'll look at them. It's because the computer's not gonna be able to grade them, the ones we have to say it. But I'm gonna look at them carefully. If there's anything wrong, get the whole thing wrong. Just because I don't have time to divvy out partial credit. Okay? And you get one shot at it because I am not gonna grade 6 versions of it because that's what I did one year and when when Blackboard lets you take 6 versions, I have to grade all 6 of them. Or it won't let me go on with my life, so. All right, any questions on that? So I'll let them both be due on Thursday and that will help. Both of those are good preparation for the exam that you have opening on Friday and closing Friday at midnight, open and closing Saturday night at midnight. Okay. Don't start it. If Saturday Night Live has started, I know you guys don't watch it, it's not that fun anymore, but if that started, then it's too late. You can't finish the exam in 30 minutes. Okay. You can try. But you're not going to be able to, I don't think. The midterm takes a little longer. Okay. Any other questions? Okay. So it goes up to mod 7. Mod 8, I didn't open up mod 8, but I will open up mod 8 probably today or Wednesday or something. But mod 7, I want you, that's where you're going to find the midterm. And that's where you're going to find the practice midterm. It says so right there. Okay. All right. The assignment that I want to go over though is something called hold on. It's something called midterm all questions, midterm exam all questions. Let's see, let's edit it. Okay, so this is not the midterm at all. There's 47 questions here. What these are all the questions that were on the quizzes from quiz 7, quiz 5, 6, and 7. If you want quizzes 1 through 4, I already went over them with you guys in class, and I live streamed it and I saved it, and I will be posted. It should be posted somewhere. If you want, I will post it someplace separately along with this one, so you know. Okay, so let's start off with some of the questions that you might see. What is 0 times infinity? So what's the answer, Sarah? What would you say? Well, you could say about the journey, but what's the answer, really? True. Yes. Sorry. It could be anything. The answer is could be anything. How many points do we need for average rate of change? 2. These answers have got to come faster. How many points do we need for instantaneous rate of change? 1. So, Kara, are you there? Oh, Kara's here today. She can answer the next one. What's the mean value theorem say? That's a hard one.
I'm sorry, I don't know off the top of my head.
Does anyone know? Mean value theorem? I think of the mean cops that give you a ticket for speeding. It's when the average change equals instantaneous rate of change. How about Newton's method? Melanie, Newton's, oh, Christian, go ahead.
Okay. Find zeros.
Find zeros, that's all. Excellent, excellent. What are some applications of derivatives if you get this question? Mahir, can you name any applications of derivatives? Two of them we just mentioned. Mahir?
Newton's method and mean value theorem.
Yep. And can you think of any others?
Average rate of change and instantaneous rate of change.
No, not those. No, other applications we did. Remember that one with the square, the local linear? Remember that?
No.
That was one. Oh, well, that's not one of them. Are there any others? L'Hopital's rule's another one.
Chain rule. No.
No. Chain rule is a type of derivative. It's not an application. Applications mean we use derivatives for something. L'Hopital's rule, we're using it to find limits. Newton's method, we're using it to find zeros. Mean value theorem, we're using it to find when the instantaneous rate of change equals the average rate of change. Analysis of functions, we use derivatives to find the inflection points in the max and mins. Optimization is an application of max and mins because we're still using, we really just use the graph, but finding the derivative, set it equal to zero, those are applications of derivatives. So there were a lot of them. Is there anything else that we did recently? And by the way, all of those applications are sort of on their own. Related rates, that was another one. These are all good answers. But anyway, we did a bunch of them and they're all sort of self-contained. If any one of them you don't know, these are the things I would cut loose the most. We use derivatives for a lot of things, but applications, your related rate is all standalone. Do you know what I mean by standalone? It is what it is. If you don't, you need derivatives for lots of things, but you don't need related rate for anything but related rates. You don't need to know, the inflection point is a really useful thing, but it is a standalone. If you don't get it, you don't get it. Okay. What are the two rates of change? Kara, do you know the two rates of change? You must. Is she there still?
I'm sorry, you broke up a little bit. Could you repeat it?
What are the two rates of change?
Average and instantaneous?
Average and instantaneous. Oh, look, I got a bunch more people here. Jake, can you answer the next question? What is what do we need for continuity?
The limit must exist, the function must exist, and the limit and the function must be equal.
Awesome. Anusha, what about acceleration? What is that?
It's like the average. It's like when, I don't know the exact definition, but it's like not the average rate of change, but it's like when the denominator of that is squared. So it's like per second instead of just per second.
Right. So a first derivative would be per second. So
So
having
second
per second
derivative.
means it's the what?
Second derivative.
That's it. Awesome. Thank you, Anusha. Okay. Average rate of change found on a curve is called the what? Something of the something line. Slope of the secant line. Very good. What is calculus? Study change. What's the derivative of cosine? Negative sign. What's the derivative of cosh? Sinh. What is an inflection point, Sarah? Max and min. Go ahead, Dana. Yes, when the concavity changes. When it changes from concave up to concave down or the other way around. Why did we invent limits? These are in no particular order, apparently. Why did we invent limits? To bring how many points to how many points? 2 points to 1 point, and the arbitrary change to instantaneous rate of change. What is math? A language. And what are another ways of saying y prime? Derivative, instantaneous rate of change, slope of the tangent line, velocity, dy dx. Okay? Are we good with that? All right. These are in no particular order, and I actually can't give you a test this way anymore. So I will be breaking them up into different groups to make sure that, so generally speaking, the first group is something really easy, like what is calculus or what is math. And then later on, they get harder. But I can't ask you a group like this because stupid Blackboard, if I say pick 4 of these, Blackboard will pick 4 of the same question. And you'll answer it once or twice, or you'll skip it because you'll think, oh, I just answered this question. And then it causes problems. So anyway, I will break this up. This is to, so anyway, but you will have these questions, and they are a good way to get points on the test. I noticed that the lowest score on the test was like 45%. So this is how you can not get a 0 on the test, is to answer the easy question. I did for the other class. I just literally added 10 points to it. I went in and I added 10 points to the test itself. For you guys, I'm just gonna add the 2 points. But what? 10.
Oh, sorry.
I added 10 points to their test. So because it's harder with the online students for them to know what's going on, they see the score, then I don't get to talk to them. So I just added 10 points. I don't know what I'm gonna do with you guys, but at least this 10 points probably. You guys did okay. So I expect you to do better. Okay, next group of questions, 4 to 10. These are short answers, say things. Okay, you had some new limits to, oh, these are all say limits. So these are, let's just take a look at them. Actually, I don't have to do it this way. Hold on, I'm going to do it a different way. Hold. Oh, yeah, no, I have to do it this way. Sorry, my bad. So, what does this say? This is a limit. There's nothing special about this limit. Just says the limit, what? Says x approaches 1 of f of x equals -2. That's just, this is the simplest, straightforward one. Okay. About this one. What's this one special? You have to add one thing to the regular one. What is it? Approaches from the left because of that minus the 3 with the little minus, that approaches from the left. So this is the limit as x approaches 3 from the left. Okay. Next one. There should be one that approaches from the right. There's probably one that goes to infinity. This one. What's this one? The limit as x goes to 5, what? From the right equals -6. Okay? Any problem with those? Oh, yeah. You'll have a limit to say. You'll have a derivative to say. You'll have a integral to say. And then you might have just 4 of them. So was there something to say that we did? Limit, derivative, integral, and something else. Maybe a higher power derivative, fourth derivative or something. But these are all limits. This one's nothing special. It just goes to, it's x goes to a half and the answer goes to -infinity. So these are not bad. These were pretty straightforward limits. There wasn't anything particularly nasty about the limits. That was 4 through 10. I'm not going to go through all of them because they weren't that bad, were they? I didn't. The worst thing that happened is you get to the right or to the left that you add to it. And maybe there's a negative sign in there somewhere. All right, so let's take a look at this group. So now this is a say something. What is this? Say the derivative. Okay. Okay, so people were screwing this up. You can say d dx of f of x. You can. Or you could just say, it's another way of saying that first term right there with the f. Yep, you can just say the derivative of f of x. You don't have to say d dx, but you can. There's various ways of saying derivative. You can say it various ways. What about the next one? The g. How do you say that? G prime, or the derivative of g, and what's the 0? Evaluated at 0, not times. You lose all credit if you say times. It's derivative of g evaluated at 0. And what about the h? Keep going. No, no powers. No powers. No. No. Anyone at home? Melanie, please help. There's no to the power, so you lose points right away if you say to the power. No, no. It doesn't even start with H. It starts with something. And imagine this test. This test is about derivatives. The what derivative? Nope. The fourth derivative. Thank you. Finally, it's the fourth derivative. Thank you, Christian Newitt. That's the fourth derivative of H. I can't, a lot of people missed that, and you know it's going to be on the next test. Because a lot of people missed it, I have to put it back on the test. So let's just remember that for future sake. That's the fourth derivative. And there's probably, look, they all have them. What's that one going to be? Right, so this is the derivative of f of t plus g prime evaluated at 1
Plus H.
with plus fifth derivative of h.
And then,
You can say evaluated at t of t if you want. You should say of, not evaluated, because it's not evaluated. I think having the variable name doesn't make it evaluated. That one is evaluated at. I didn't, even with f, I don't even have to, just that first one says derivative of f of t. You can say d dt of f of t. You can say that, or you can just say the derivative of f of t. If you're not taking the derivative with respect to something different, there's the variables, you don't have to say anything. Just say it's derivative of f of t. As long as the variables match. If they don't match, that's a problem. Then you have to say d dt of f of x. That would be variables not matching.
So you can just say.
You can say d dt. You have to say it that way. Not d over dt. That would be wrong. So when I'm saying you're in a calculus class, I just want to know that you know there's lots of ways of saying these things. There's no absolute right or wrong way to say anything. It's true. It's a language. It's like in English. The ways are said, but just there are ways of saying it that are wrong. You know, there are just things, just like in English, there are just things you just don't say. Okay. I was thinking of that song. My name is, they call me Stacy, they call me whatever. That's not my name. That's not, I love that song. They call me her or something. That's not my name. Okay. So you can call them a lot of things, but just make sure that they're correct. Okay. See here, now this is the derivative of f of z. This is, what is that? What's that? You can say g double prime evaluated or evaluated it to, and then that's the fourth derivative. Very good. Okay, so that was the third group of questions you could be asked. If I was just assign this, I could see them all, but you know, I'm just gonna assign this assignment. Hold on. Hold on. Give me a moment here. I'm tired of maneuvering this horrible thing. Test. Practice midterm, all questions. Okay. Make it available. Hold on.
This question, yes.
What are you saying? What are you saying? You have a question? Okay. Oh, this isn't gonna work either.
Oh, just right.
That's okay, we'll try it. Okay. So those were derivatives. Okay with them? Here's the next one. This one is the only, there's more than one integrals that this one is one of my favorites. Actually, I think it's the only one on this thing. The antiderivative of, or the integral of, no, in this one you have to say the integral of f of x dx equals, how do you say the next one? Say it. Antiderivative of f. Okay, you can't say little lowercase and capital F. You have to say antiderivative. That capital F is the antiderivative, and then plus C. Okay. So here's the question. What happened here? This boy, you know what this looks like a test to me? This isn't what I thought it was, but this is exactly what I'm talking about. You have to click all that apply. What do you see? I brought that 2 down. That's a power rule right there. There's an inside function that's left alone, so that's a chain rule. Do you see a product or a quotient rule? I didn't see no quotient. I don't see no chain. I don't see any product. I can.
It's not good for you, but it's not for everything.
No, I have to teach something new.
Or at least ask for this.
Okay, moving on. This question right here. Here, I'll review now. What is this? Hold on. I'm reviewing now. This is a good review. This is the what rule? Is it exactly the quotient rule? Is it the bottom times the derivative of the top minus the top times the derivative of the bottom, all of the bottom squared? Yes, and I didn't do anything. There's no chain rule because there's an inside function here, but I didn't touch it. So with that, there's no chain rule being done. There's no product rule because it's not first times derivative. Like there could be if there was a product inside, let's say the sine. There was another, there was another cosine inside there, but no. Was there a power rule? Did I do any power rules? No. Very good. All right, next one. How about this one? Okay, I see the 36 here, and then the next line I see the derivative of 36. It hasn't been done. Yes, seeing this right. I looks like I took the derivative of everything. And I just wrote derivative. I didn't do anything. This one right here, the first one, if I keep going, we'll have more stuff. Sarah. Right here, if you bring that power down, and you subtract 1 and then take the derivative of the inside, that would be a product rule. That's a product rule waiting to happen. Because it's x times y. But nope, this one right here is just a power rule. That's just a quick and dirty method. But this is just implicit, nothing else was done. Okay, you should not expect me to try to trick you too much on midterm. I know you think I'm going to ask you lots of things, but okay. So what about this one? Are you sure it's just the quotient rule? You just want to second guess this. This is just the quotient rule.
No, it's not.
It's the bottom. times the derivative of the top minus the top times the bottom, all the bottom. Right. I didn't do anything else. Nothing. I just wanted to check you, Sarah. You said, I'm going to pick more, and you would. And it's just, I know, so don't. Just, it's fine. You'll do it. You'll be fine. You're scared that you're going to overdo it. How about this one? Now the implicit's already been done. So the first line, you can see it isn't something before it became this, but now what happened? What happened, Sarah? I took the derivative of y cubed, and I got 3y squared, which is a what rule? Power rule. And then I took the, where'd this dy dx come from? That came from which rule? Chain rule. Is there a product rule in here? What's that 2xy? It's 2x dy dx plus 2y. That's the product right there. So it's everything except the implicit that's already been done. Okay? Tricky. Okay, what's been done here? Power rule, because I brought the 11 down. Subtracted the power, left the inside alone. Which rule is that? Chain. There's no product and there's no implicit. Okay, are we good? Oh my God, this is the epsilon delta on here. You wish. This is another, this is, how do we find, does this formula help us at all? I don't think there's any epsilon delta formula in here. But look, there's the product rule right there, and there's a quotient rule. I don't see any epsilon delta here. This is one of those obscure applications, and I do usually take them out. This was on a quiz, and so that's why it's on this assignment. But didn't you have it on a quiz? In case somebody wants to know how to do this, I will copy this. Copy, go into my Desmos that I just had open. What? Go ahead, say it. Backward? What? Ugh, just screwed this up. I can't hear any people at home. Okay, so that's what it says. Symbolically find this for this function. So this is what I do. I take this. I take the absolute value of the function minus the limit, which is 4. And I say that's less than epsilon. Best way to do it is to copy it from here, I believe. There. See, so I did the function minus the limit like this. And then I copy it. I know you're not paying attention, but I'm doing it anyway, just in case I lied. It's on there. Okay, what is 1 minus 4? That's minus 3. It's minus 3. Get rid of this. So I just combined them. So now I'm going to factor out a 1/3. So we're going to take a 1/3 out of here. And when I put it out here, 1/3, that's going to end up being 9. Okay, and that number there had better match the number here in the limit, which it does. So we're good. Now what do I do? What should I do, guys? Anybody? Now I get rid of that. I'm going to move it to the other side. And that's the answer, 3 epsilon. I multiply both sides by 3. Okay? And that's the epsilon delta thing. So the answer here would be, how many multiples of epsilon? It would just be 3. All right, now about this one. The state code one. I think I can copy this whole thing. Ugh. No, I gotta remember to put the little thing in first before I copy it. Nope. Hold on. There. So what I have to do is at 19,600. I have this has to be continuous. So all I have to do is put 19,600 into both of these functions. It's really hard to read, but I have to put the 0.12x, that's one of them. And I have to put 19,600 in for it, 19,600 for x. And I get 2352. And then I have to do the same thing for your b plus 2. So let me just copy that down and put it here. So I have to put in 19,600 for x. Okay, do you see how the 19,600s cancel out? And all I'm left with is b. So these have to be equal. 2352 has to be the same as b. So what is b equal to? 2352. Okay. All right. Then we have the car. Now, we've done this so many times, and you know that Professor Porter likes to put this on the test. So this is probably a formula worth memorizing. Does anyone remember what the formula is? The formula is x prime plus y prime divided by the square root of, hold on. The formula is x prime plus y prime all over square root of, which is it, x or y squared. You want to remember? It came from the Pythagorean theorem. So it's either x or x prime, which is it. Pythagorean theorem is better to be x squared plus y squared. Okay, that's the formula if you want to memorize it. And that's the answer. So let me just put the question in. All of these things are cars traveling. That's x prime. That's how fast it's traveling. That's a distance, so that's x. And then this is y prime. And this is y. So all I have to do is plug those things into this formula. So I have to put in 27 times 1/5. And then this one is 71 times 3/5. And this one is 1/5 squared. Right? Yes. And this is 3/5 squared. Okay, and this answer is 75 miles per hour. Okay, if you happen to get this, oh, that's fine. This one is a related rate problem. It will never, we didn't do any discussions as related rate, so you can never present this. So the answer is just 75. Whatever. All right. The slope of the tangent line of the point. I saw a lot of people missing this. I was a little disappointed. Okay, the slope of the tangent line. Ugh, killing me, they're killing me. Slope of the tangent line. And remember, these are squared. So I have to take, I'm copying this ellipse. I'm putting it in here. And I'm remembering to square for these things. There. Looks very circle-like because 5 and 4 are not very big for them. So anyway, there's a point 1, 2 is definitely a point on that thing. So we want the tangent line there. How do we find the tangent line? We use implicit differentiation. We don't have y explicitly, so we just take the derivative. Dx. 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 Okay, and what do we get? Let's do these derivatives. What do we get? What's the derivative of 5x squared? 10x. It's the derivative of 4y squared.
8y.
Y. And what's the derivative of 21? 0. And now I have to plug in the point 1, 2. Right? That's the point we have. If I plug 1, 2 in there, that's to make any sense. What's missing? Here. If I plug in the point 1, 2, I got this. I know you're going to contort yourself to find answers, but there's something missing. When I plug in 1 for x and 2 for y, I get nothing to solve for. That's just false. 10 plus 16 is not equal to 0. What did we forget? What's the derivative of 5x squared? That's easy. The variables match. Everything is good. What's the derivative of that? There's a power rule, but we're taking the derivative with respect to x. These variables don't match. So what rule do we use then? Because with the shape rhymes with pain. The chain rule. So you have to take the derivative. So you have to multiply it by the derivative of the inside. In this case, it's just, you don't know, the inside is just y. So it's dy dx. That's what you're looking for. Without it, you have nothing to solve for. Okay, so we put it there. And now we can solve this. So that's 10. So it's minus 10 over 16. So dy dx equals minus 10 over 16. Okay, if you wanted to, you don't have to. That's the answer. But if you want to see the picture, just to make sure you're right, you could do y minus 2, because that's the y value, equals minus 10 over 16 times x minus 1. Okay, how about just minus 1? Does that look like the tangent line to the curve at 1? It does. So our slope of minus 10 over 16 is correct. Would minus 5 over 8 be good? Minus 5 over 16? Not good. It's non-tangent. You can see that's a secant thing. That's not a tangent. But minus 5 over 8. Would that be good? Sure, that's still good. Okay, now just simplify it. So those answers are both good. Minus 5 over 8. Okay. Give that as a, it says give us a decimal. Oh, so I'm going to get that wrong. What's a decimal for 5/8? .625. Okay. Oh, what are you saying? Oh, it said it wanted to do 1.625. Okay. Let Desmos be your friend. They give you Desmos on the PSAT? Oh, you are kicking butt then, aren't you? But you do.
But I have my numbers.
What?
A calculator, I have my calculator.
Should use Desmos. I'm telling you, this is the way. I gave it to one of my students who went out into industry and became an engineer, and he was using a stupid calculator. And I said, we're not using that anymore. I showed him to use Desmos, and then he impressed his boss with his calculation. He'd do a nice graph for him, and it did everything, and he was on. Boss was impressed. He wanted to take me out to dinner, but he lives in Kansas or some god awful place I will never go. Sorry, these things are recorded, and who knows, maybe I'll be teaching in Kansas someday. No, it was Kansas City. It's in Louisiana. It's in St. Louis. That's where he lives. He's gonna watch this video. I know it. I'm gonna pay for that statement. Sorry, I love Kansas. Actually, you don't know enough about me to know why I would say I would never go there, but it has nothing to do with the people or the climate or anything. I love people everywhere. People are cool. Culture is cool. I myself have a hobby, and they don't do my hobby there. I don't want to tell you. It's too personal. That's going to be recorded. You can ask me later. Anyway, here's 6x cubed. Here's a limit. It's like, what is this hobby that they don't do in Kansas? But they do it in Florida and the Carolinas. It's sad. I like those places. Is nobody going to tell me that I can't function anymore? That's what, Sharon? All right, there it is. What the heck is this? Evaluate the limit x rightwards arrow to what is this? Is that how it copied over? Oh, it's this. The limit of so copying it over made it a disaster. Well, how do I do this problem? Anyone? 6x cubed over e to the x, I'm going to infinity. Desmos really copied it over terrible. So let me just write it as a function. 6x cubed divided by e raised to the x. Let me turn all of these off so you don't have to see them. Anything else on here? Okay, so there's a graph of it. And I'm going to infinity. So where is this function going to infinity? Anyone? Looks like it's going where? Does it? Oh, suck up. Okay. It looked like it was going up, and now it's doing what? Sorry. Even I was fooled. I was like, oh, I gave you an answer. It goes to infinity. That's so weird. Anyway, here's what you could do if you're not sure. Just plug in a really big number, and it goes to what?
0.
0. Sorry. Leave sooner than I know. Okay, what's the derivative of this? Oh, this is a multi-part thing, but it's one that we just did. You have to bring the 9 down, and 9 times 3 is 27. So that looks like I. So we'll put an I there. And then the power, that 9 is going to lose a power, and it's going to be 8. So that would be G. So C is going to be G.
No.
This is, you won't get this on the test because this has to be multiple choice so it can be graded, but I just say find the derivative. I'm not going to make you knowledge. No, you did. The one I told you, we pick as many that apply. The reading comprehensions. Why? Is that useful in life? Do you think that's going to happen to you? Do you think your PSAT, do you think after you took that PSAT test, that you're ever going to see those tests again? Ever? Oh, yeah, the SATs. And oh, yes, the GREs. Oh, yeah, when they're all done, when you go to get an industry, they're not going to be like, okay, you're starting to work here. Here's a multiple choice test. Tell us, are we the best company, the most awesome company, your favorite company? Choose all that apply. All right, B is this one, it's A, hold on. And then I have to do what? I've done everything, and what's that D at the end? Remember, I bring the power down, I leave the inside alone, I subtract 1 from the power, and then what do I have to do last? It's a chain rule. What do I have to do last? Take the derivative of the inside. What's the derivative of the inside?
X plus 14.
What's the derivative of that?
6x.
6x to the 5th.
Plus x.
That's not one of the choices.
Okay.
It's either 6x to the 5th or it's 6x to the 5th plus 1. It is plus 1. There you go. Aren't you glad it was multiple choice? You wish. Okay, calculate to the best of your ability this limit. It's going to infinity. So I can put that into Desmos if I like, and just put in a really big number. Or I can use L'Hopital's rule again and again. I do it twice. I do L'Hopital's rule twice for this. Okay, or I can remember pre-calculus and know that that's the horizontal asymptote at the end, and it's the leading coefficients, the 4 and the 2. So the answer is just going to be 4 over 2 or 2. Would you like to see that? I'm not going to do that again. Just plug this into Desmos and do any of those ways. Finding a limit. I don't care if you know L'Hopital's rule or not anymore. We did it, we covered it, you heard me say it, but if I ask you to do a limit, and I'm never gonna say use L'Hopital's rule to find the limit, I'm just gonna say find the limit. You can use any of the methods that we have had so far. Okay? And that would mean just plug the number in or graph it or whatever. All right. Local linear approximation. I love this one. This one's a favorite of mine because it's cool. It's cool. It's a local linear approximation. It's the best. Look, find the local linear approximation function square root at, so you're going to make a local linear approximation. So I'm going to go into my formulas because I know I have it, the local linear approximation in for here, which is just a line formula. This is it right here. I'm going to take this one and I'm going to drag it down to the bottom. Okay. Okay, and I already used this function here, so I'm just going to make that one not. So use this one. So I want f of x to be, what's the function here? Use local linear approximation to find the square root at a. So what am I going to do? What's the function that I want? Anyone? Use to find the square root of 7. What's the function? What's being done here? A function is a job. What's the job? No. What are we being asked to find here? Use the local linear approximation to find something. What are you trying to find? Square root. If that's the function, that's a job here, trying to find the square root of 7. What is the square root of 7? Does anyone know? 8.33333. That would be the wrong answer because it says use the local linear approximation. So I need to use the local linear approximation. That's this thing. All right. So they say square root at a equals 9. So what do I have to do to this formula to be able to use it? I can add a slider at 9. Or I can put 9s in for all of those things. And there I have a tangent line at 9. See that? This is an application of derivative. Derivative is slope of the tangent line. There's the slope of the tangent line right there. There's the equation of the line centered at 9. Okay, now what? That's the purple thing is the local linear approximation. Now what I want to do is evaluate what? I want the local linear of what number? Oh, I didn't say 70. 7. I want the local linear of 7. What does that say? 2 points. So are they close? Is that close to the square root of 7? Yes. The correct answer here is 2.666, not 2.645. If you give me the square root of 7, I'm going to mark it wrong because you did not use the local linear approximation. You just used a calculator to find the exact answer. Okay. We use I don't look in your future job. You might look at a function and say, I just don't want it. I want it to look like a line. Your boss is only going to want simple lines. People only like simple lines. They don't like square root functions. So this is why we've used a local linear. We turn whatever function we want into a line. But you can't turn any function. You can't turn this function here. Hold on. This one here that was messing you up earlier, this guy. Now you can't turn that into a line. But at any point you zoom into, it looks like a line there, doesn't it? Any point you over here, any place you look, you'll see a line. So rather than try to work with the ugly function, if you know you're only going to work around here, then just instead of using the function, use whatever the line is. And to find the equation of this line, you find a point and you find the tangent line, you find the derivative. Point and derivative, make a line. Okay. Could do it other ways, but that's all right. Any other questions? So it was 2.666. 3 decimal places. All right. determine where the graph of that is concave down. Okay. All right. Concave down. How do we find whether something's concave down? Anybody?
What is it? And
What do we have to do? I'm going to take this function here, copy it. I'm going to use a different letter. And I'm going to raise these up, raise this up. So that's the function. Anybody at home want to tell me what I have to do? Who's at home that I haven't called on yet? I've called on all these people before. Melanie, I don't think I've heard your voice. Can I hear you yet? She's at home. She was at home. I just saw her name. Saw her name. Kara. I've heard your voice already. I can't call on some of these people because they're online students. Or Anusha. Anusha, what do I do to find out concavity down? Concave down means what?
Like if it's opening, like if there's a maximum point, if it's opening down.
It doesn't have to have a maximum point. But
Oh,
a maximum would, at a maximum, it would be concave down, but it's concave down everywhere around there. So if you just look at a little piece of it, like that graph we were looking at before, let me just go back to that graph. Okay. This right here is, there's the maximum, right? So that's concave down, but I could be looking at a piece of it. Let me just zoom into a piece. Here's a piece that's concave down and there's no maximum, it's still concave down. As long as it's curving that way, as long as it looks like a piece of an N, it's concave down. Please note it changes to concave up. Oh, it's concave down here too. This is down and that's down, but is there an up portion right here? Yes. Is there an up portion over here? Yes. How do we know? What are we looking for if we are changing from concave up to concave down? What are we looking for? What's the point called? It begins with an I.
the inflection point.
How do we find the inflection point?
By like getting the derivative.
Second derivative, say it louder. Second derivative equals 0. Okay, so let me just turn off these other things that I have. So here's the function that we're looking at, p of x. Oop. That is some hard to see function. Okay, that's it. If I zoom out, it's a cubic function, it goes up, down, up, but it's all squiggly. If I do this, if I'm smart enough, you don't have to be smart enough to do this, but if you're smart enough and you can do this, you can get it to look nicer, maybe. And then maybe you can play around with the window in some other way. That looks like a perfectly normal problem you might see in a calculus class. And where is it concave down or where is it concave up? Where does it change? What is it here? Is it concave up or concave down? Is that a piece of an N or a piece of a U? That's a piece of an N. Over here on the other side, is that a piece of an N or a piece of a U? U. So somewhere it went from up to down. So this is a U and that's an N. So probably around here somewhere. How do I find that number? I said the second derivative equals 0. That's that number. I don't know if it will tell it to me. There's various tricks you have to use on Desmos to get that answer. It looks like it's minus 5.5. So the question is, when is it concave down? Concave down is when it's not equal to 0, but when it's what? Greater than or less than? Concave down, less than. There it goes, and it's shaded in. So I know by putting that less than, I shaded the region. That's what I want, the purple region, yes? So the answer is going to be, well, minus infinity to minus 5.5. Or they're not gonna ask you in a decision, they're gonna say, what is the answer? It's just gonna be X is less than minus 5.5. Okay? Concave downward, X is less than value minus 5.5. Okay, are we good? That does most all work. You could take the second derivative. You could do all of that by hand. But, okay, calculate this limit. Oh, well, look what we got here. We have a click on the following Desmos example and then find the limit to 21. Desmos example, don't mess with the data. Sometimes people go up here and they say, oh, 20 is 1,000, so 20. No, that's the data. This is the regression that we want the regression evaluated at 21. It's that number, 1119. The answer here is 1119. And if you were putting in units because you were presenting a limit, because that's how I like to do that, is present limits, you'd have to go back here and look and see, this is time and distance. So in miles. So is the answer 1119 hours? Is it miles? Is it miles per hour? What is it? It's a limit. It's a limit. It's not a rate. It's a value. So which is it? Say it louder. It's miles. So the answer here would be 1119 miles. Okay. A limit just has values. There's no per in limits. No, the x value we know is 21. That's the y value. Some people do that. If they go like this, they go to 21 and then they look at 21. But sometimes you get the wrong answer. Well, that's the right answer, but sometimes Desmos isn't exactly right and you're off by a little bit. And then you make me look at how you did it. And honestly, if you did it that way, that's okay by me. If you don't, but if you remembered this answer because you saw me, but you were like, I remember this question. We went over it in the review and you type in 1119 and you type in 1118 and I look at your work and there's no work, then you don't get any credit. So these Desmos questions are really easy to do. I'm not really trying to tax your ability to do any calculations at this point of the test. You're probably tired. You've done all these calculations. So the hard part is the presenting part. Okay. Okay. Use Desmos length, time amount 20. Okay, so I'm just going to click on this and it wants me to type in 22 hours. So when I go in here, oh, my bad. I want 22 hours. So they don't have 22. So let's put in here 22. Oh, it looks like they want first derivative. So it's 1271 and then 172. So it's 1271. 171. Oh, they want the second derivative. How am I going to find that? I definitely can't find the second derivative at 22 on the, if I go to 22, barely I can get the one answer, 1271. Sure. How do I get the second derivative? Someone's telling me I'm not doing it. Somebody from home. Anusha. How do I get the second derivative that I'm asked to get?
Would you just like look at the table and then like plug in like u double prime of x?
I did. I typed 22 into the table, but I'm not seeing a second derivative.
Oh. I don't know. Sorry.
Okay. Anyone? No, you're right. The right idea. Go ahead, Dana. What do I have to do? In another line, maybe like this. I could do that. 41. Very good. Thank you, Nana. Or I could do something else. I could just simply expand this bar over here and see the second derivative. Oh, it was there the whole time. Yeah, that's one of the Desmoses. There might be stuff there you can't see. Okay, I usually give you all three of them because I just told you I didn't want to make it hard. But any of those ways would have been fine. The answer is 41. Okay,
So, I just have a question. I don't know if you already mentioned this, but like, are we supposed to round or can we just give can we just cut the number?
that is not calculus. So it's not really worth anything to me, whether you say it rounded or chop, follow my instructions to round it or chop. I don't really care. On the computer graded stuff, if the computer's grading it, you have to do what it says. Or the computer's gonna mark it wrong. And then if it's a test, I have to look at it. And then I look at it and I give you your points back. Okay, I do not take off for that. I don't
Okay.
take off for algebra. The only time I take off points for things like that is if I need you to look at them. Like, in other words, if you made a mistake that's more serious, like I do take off for forgetting parentheses though. If you're doing aggregated change and you don't put the parentheses in, that really changes the answer. But if you gave the wrong answer because you didn't know any, I don't care. That's why my questions are so sloppy. Because when you're saying them, just give me as many decimal places as you want to give me. It says 1 decimal place, you have to type it in as 1 decimal place, it'll mark it wrong. But for these ones where you have to present them, you can just say 171 or 271 or whatever, and that should be fine. And if it isn't, if you had the right answer and it was on Desmos and I recorded it as I would have on HonorLock, you can always say, could you go back and look at HonorLock and see that I had the more decimal places, I just chose to give you less because you weren't clear. And I would say, sure. But it doesn't usually get that far. Okay? Did that answer your question? Did it? Are you upset? I really, it should say, after Sarah hollered at me, I changed a lot of them to say to 1 decimal place. I went back and I tried to make sure, but even then I found some that were not that way. This
Yeah,
is what
sorry, I was muted, but that really does help. Thank you.
okay, good. I honestly don't I have to maintain all these questions and I keep changing them every year. So there's probably mistakes in them. And if there is, just let it go. It should and let me know about it. Sometimes I noticed that some people sent me, this happens sometimes. You open up a question and it doesn't, nothing pops up. It says find the limit and then there's nothing there. So wait a little bit and then say to me on the screen, nothing came up. Or even type in it, nothing came up. And then I'll watch the video and then I will usually just give you credit for the problem. Okay. What? Give you credit? And I usually don't, but it's sometimes harder for me to figure out. Normally what I do is omit the problem and give you credit and like omit it from your final and then change your grade. Like I just omit the problem. I don't make you do the problem. If you get up and go to the bathroom, which you're not allowed to do during the test, I can either take that question away and not give you any points for just that question. So that's not the worst penalty. Or I can omit it. But if it's something I want to know the answer to, like if you had the right answer, you got up and you walked away and you went to the bathroom, I usually just omit them. I don't give any credit for them. But I don't give you 0 either. I just take that question away. It requires some math on my part. But that's what I do for a living, so I don't mind. All right, so this is predict something with the second derivative equals 0. Predict where the second derivative is, and then give that point to 1 decimal place, and then put in words what that means. All right, so what am I doing? I want the second derivative equals 0. So this is the function. The second derivative equals 0 is what point? Is it a max, a min, or something else? It's an inflection point, and somewhere around here, maybe. Okay, so how do I find that? Well, if I turn on the derivative, you can find that inflection point by looking for the max, the derivative. So that's where the inflection point is right there. Or I can do what else? What can I do, Nina, to find the inflection point? I don't know, I just said X. Yeah. That's the same, so there it is. And so it happens at 6.975. Okay. So at so predict where the second derivative, that's at X equals 6.975. No, 6.975. Oh, to 1 decimal place, so 7. Okay, in words, according to the blank, there is a blank at our blank. So the hour is 7. There is what is that? What type of point is that, Sarah? Selection point, and then according to the what? There was data. It must have been the cubic regression. Sure. I have some, so let me just, I'm just feeling a little guilty about these questions, but I'm not really. I'm feeling guilty because this is totally new for both of us. Not totally new for me, but it's totally new in that the idea of justifying your answer by saying, according to the cubic regression, there's an inflection point at this. You probably never had to do that before. They just say, where's the inflection point? And that's it. But what I'm trying to tell you to do is when you're giving people answers, tell them where it came from. And in this case, it came from a cubic regression. Okay. That's kind of new to you. I'm sure nobody else does it. And I feel a little badly about it because I know the math department would be like, why are you doing that? That's crazy. But they didn't work in industry. If you work in industry and you're giving an answer, you got to say where it came from. You cover your butt that way. So I mean, cover your. All right. Putting between the 5th and 20th hour of travel. So I'm going to copy this over. And I'm going to make sure I put it in parentheses, 5th and 20th. So I'm coming down here and putting this in and saying, according to the blank regression between the 5th and 20th hours of travel, the regression here is a quartic regression. Quartic regression. Between the 5th and 20th hours. Okay, so A1 will be 5. Now between the 5th and 20th hours. The mean value of them is satisfied given in the what hour of travel? Oh. When is it satisfied? So look at what's graphed here. It's not the function that's graphed. These two things are graphed. That's the average rate of change. And that's a graph of the derivative, the instantaneous rate of change. So when are they equal to each other? That's what the mean value theorem said. When is average equal to instantaneous? When did that happen? Here? Okay, that's not between 5 and 20. So that one. Which is the one between 5 and 20. Right here, this one. Wow, look, there's another one. So there's 2, 17 and 8.5. It says, give us whole numbers, so it's 8 and 17. I think, according to the, what regression did we say that was? Quartic? Between the 5th and 20th, the mean value is first satisfied. First satisfied, so which one do they want? Yeah, they want the 7th. And the 7th hour of travel, give us a whole number. Okay. Any questions on this? All right. According to the blank regression in the 9th hour of travel, we will find blank miles per hour. Oh, wow. Okay, so this is it's the 9th hour of travel. Okay. Let me just copy this.
There's something similar to the quiz, right?
These are all came from the quiz. Haven't you seen all of these before? Yeah, you didn't see all of them because you didn't take all the quizzes. Every time you take a quiz, it gives you a different version. So if you took, that's why I'm going over this, because honestly, this is all the quiz questions. It should be all the questions on the quizzes. It's not necessarily all the questions on the exam, but it's. I just every single time I don't learn. According to which regression is this? Oh, it's all folded up. It's the quartic regression. Okay. So fine, according to the quartic regression. In the 9th hour of travel, 9th hour, so put a 9 in there. We have gone how many miles? 563 miles. Oh, 1 decimal place. 563.5 miles. Plus or minus. No, 19.9 miles. This represents a what? 3.5. Be glad that I don't make you remember all of these things that go up there. Yes, you're welcome.
So would it be like that?
Was on the quiz, it would be on the test. I mean, this on the midterm, yes, this is an error question, and it's an error question from data. So you got to understand, you did error as a discussion, and so I like it as a discussion. When I can ask these questions on the test, I prefer to ask the discussion ones. Okay, an error is a application of derivative, and it's a very limited application of derivative. So I don't like to ask those as questions if I can ask them as discussions. I like discussions better. I know discussions, oh, and that's it. Those are all the questions we had. There's no way this is everything. Let's look at quiz 7 because, oh, you got to take quiz 7. I'll go over it next time. I feel like something's missing. These look like derivative stuff. I don't, oh, there was, what did we do since the derivative? L'Hopital's rule, optimization. We did these things. And we saw one thing about anti-derivatives. There was one thing, and that was it.
Oh.
But
Yeah,
somebody's talking. Okay. Anyway, I feel like this is all the quiz questions, and let me take a look at quiz 7. What the heck? Where is quiz 7? First teacher. All right. There it is. Again. All right. Question. What are critical numbers? See, that wasn't on that list of things. What are critical numbers?
Yes. As size of the derivatives,
Very good. That's a good question. And all these other ones, the antiderivative, you know what the answer, that undoes a derivative. Second derivative at a critical point is negative. That must be something about this, the maximin or something. Optimization is an application of derivatives, indefinite integral. Yeah, there's some good questions there. Say this. Ooh, this is different. How do we say this? Oh, there's choices. I know, I hate that. I tried this notation. I like the other notation better. The integral of 3 dx equals 3x plus c. So it's the first one. Don't write it on the test that way. I don't care how you write it, just say it the right way. Okay? Any questions? Okay, what happened here at lines 2 and 3? What happened? Oh. No algebra. There was a p, and then there's a p prime. So what's that? What's the difference between p and p prime? What's another word for that? derivative, and then it's equal to 0. So what are we doing? We're setting p prime equal to 0. We are, let's see what our choices are. Algebra. No. Quotient rule? No. Antiderivatives? No. Optimization with the second derivative test. I see no second derivative, so no. Finding critical points for optimization. What's the critical points? That's when the derivative is 0 or undefined. Would be that one. Using a constraint to reduce a variable. That's one of the optimization points. So no. So that's the answer. Not too bad. Did you want to go back and see the other ones here? The other ones. This is reducing a variable. You see how the A has an X and a Y in it? And now it don't. Or the perimeter has an X and Y in it, and now it don't. That was using a constraint to get rid of variable. And that's the constraint right there. Got it? This one. Okay, so I have a function. I take the derivative, I set it equal to 0, and then I do what? Second derivative. So what is this? This is the second derivative test. I found the derivative was equal to 0, and then I took the second derivative, showed it was negative. So that's the second derivative test. If I were to graph this, you'd see there's a maximum here at 12.83. The second derivative is negative. That's how I know it's a maximum. Okay. That's interesting. All right. What is this? There's a distance. The distance is the same. Right? I have a distance of something, and then I have another, I have two things. And then in the end, what happened to my y value? It's gone. So what did I do? No. I used a what? Begins with a C. No. This is an optimization problem. I'm starting an optimization problem. But I'm using a constraint to get rid of a variable. This one has two variables. This one has one variable. So that right there is the constraint. Up here, remember, here was whenever you see two functions next to each other, it's a hint that's a constraint. One of them's a constraint. Okay. What about this one? It is another, that's a function of two variables. It's a function of one variable constraint. It's just, I know, you're looking and say, oh my God, look at all that crap. This is what I'm hoping you'll learn in life. You'll be able to see through all the crap and say, I don't need any of that. All I see is this function had two variables and now it only has one. Okay, good. How about this one? No. That's r of x, and this is r prime of x. So what did I do? Took the derivative. That's it. I don't know which one. When is there one that just take the derivative? People know I have plan. You watch. Okay. Just the derivative. That's all I did here. Maybe I'm trying to optimize it. I didn't do the second derivative test. Wasn't there one before where we just did the derivative for the first one? We did the derivative and we set it equal to 0. Okay, so they didn't set it equal to 0, they just took the derivative. But maybe they're about to set it equal to 0. I don't know. That's the best we can do that. Okay, what about this one? That's just an antiderivative. And this one, what have you been saying all along? No, you haven't been saying that all along. Every other word out of your mouth has been something with an S.
Algebra.
Algebra, that's it. It's algebra, that's all this is. There's nothing here. They didn't do any antiderivative. Here, they did the antiderivative. It's done. There's the plus C and everything. Here, there's no plus C. They just distributed some algebra. That's all it is. How about this one? Algebra or antiderivative? Antiderivative. There's the plus C and everything. Okay. Good. So now I've done your quiz for you there. What's the other question? Oh, next one. A three-sided fence. Okay, so these are hard to do on the test because I don't give you paper. You know who I'm looking at. Paper wanter. I don't know. She can't live without a dead tree, but it's fine. I want but this one can be done just on Desmos, especially if you know what you're looking for. Especially if I ask this exact question, you don't have to draw a picture of it. Okay, so here's I'm going to click on the Desmos, and this is just a regular formula sheet. Read the question. A three-sided fence is built next to a straight river, which forms the fourth side of a rectangular region. The inclined region is equal to, the enclosed area is equal to 87. So area equals X times Y, okay, which equals 87. Find the minimum total perimeter. Well, the perimeter is, this is the hard part, the perimeter is 2x plus y. There's two x's and one y. That's why it's three-sided. Okay? So what you have to do is you have to take this formula, put it into Desmos like this, and then you have to say area, this area here, area is equal to xy equals to 87. That's the constraint. Xy equals 87. So that's another way of saying y equals 87 over x. So now I'm going to take this perimeter here, and I'm going to take 87 over x, and I'm going to replace y with 87 over x. Watch it go, and there it's gone. Okay, now I have a graph. Somewhere is a graph. There it is. And what I have to find the minimum. It says find the minimum total perimeter. So there's the minimum right there. So what's the answer that I want? Do I want the 6 or the 7 or the 26? I want the perimeter. That's the okay. This is a question to put on exam, and I understand that by not being able to draw the picture. On the quiz, I think that there's so much as a picture drawn, and it's labeled X, Y, X. So I know you're at a disadvantage by not having a picture. Desmos doesn't. What I'm doing right now is not Desmos, it's Zoom. I'm writing on it using Zoom. Picture. Desmos does not have that. If I'm smart and clever, I might give you I might give you a picture by using equations, but I would rather not. In other words, a folder where you click it and you turn it on and it would draw 3 sides and it would be all. I could do that, but I don't want to do that. I just as soon not ask the question. Okay. This was a quiz, so you didn't have any problem doing it, but I have seen it on tests. Okay. I have. All right. Was there another one? Was that it? What happened to question 5? I can't go back. I missed, oh, there it is. Oh, I skipped over 4 and didn't say anything. Okay, I click on this at week 30. So I'll copy this. Copy this. Copy. Click on that. And then I'll go down here. Paste. And I did it again. How come you're not laughing at me? I would be laughing at me if it weren't so sad. I did this every single time. Well, not every single time, but like most of the time. Okay. I clicked on the thing. They want week 30. So I just come in here and I put week 30. What are they asking for here? The error? Well, there they are. According to the cubic regression, this is cubic. The number of cases will be 1480 plus or minus whole numbers only 104, and that represents a 7% error. Okay. We did error before, didn't we? Okay, so that was on the quiz, but there could be other things on the quiz. Shall I look to see what else is on the quiz? Okay, let's see what else is on the quiz. Okay. Quiz. I missed those questions. Oh, because I didn't put anything in. All right, quiz 7. There were 7 of these. There were 7 of those. I already went over them. There were 5 of these read out loud things. There was 1 of these. There were 9 of these that were, we went over all of those. What were the different types? There was only 2 questions here, the river fence and the open box. You'll remember the open box, yet another observation that you don't have a picture of. You want to see the open box question? A sheet of paper is folded. So it would be an optimization one. So where it was here. So let me just say this. A sheet of paper, but give me a number. 12 by how much? Another number. 36. So that's a weird piece of paper. We're going to cut the corners, exit, and we want to fold them up, and then want to find the maximum volume. So the volume is equal to the length times the width times the height. Okay. All right. So it's a function of 3 variables, but we need to start putting some constraints on them. The height is definitely going to be X when we're left over with. We're taking 2 pieces off of each one. So one of them is going to be 12 minus 2x, and the other one's going to be 36 minus 2x. Okay, times x. That's the function we want. And it says find the maximum of that function. Okay. Okay. Go here and give myself some more y's. Okay, but where's the maximum of this function? Here. There. 2.7 or 54? What do we want? The 2.7 or the 54? Well, let's ask what the question is. Find the x value that maximizes the volume. So it's 2.7. Okay. So x equals 2.7. And that's the answer. All right. So you either have, for optimization, on the quiz, you had 2 questions, this box question or the perimeter question. There's a lot of other optimization questions I could be asking. But no those 2, because if they come up, you don't want to mess them up. All right. Makes you feel any better? I'm not very imaginative anymore. In other words, I'm okay giving you one of those 2 questions. But I might still come up, but sometimes I'm bitter. I'm still writing the test. I have to rewrite the entire test for Thursday night. I do, because that doesn't say speak out loud. It doesn't have all the rules in it. Oh, by the way, I've changed the rules. I didn't tell you this. So you know how there's a whole bunch of crap that you have to read? I'm making little links, which is a problem because they have to be in, those links have to be in HonorLock also. If I forget to do that, they won't go anywhere. HonorLock will accuse you of cheating. If there's just some problem, you can't open it, but they're just the instructions that were on the last test. There's nothing new. You say it out loud, but I don't want a whole lot of crap on the screen. So really, all you're going to see is question number 1, boom, and then like here's a link, and there's some links. Like there's going to be links, and not like a bunch of just. If you want the instructions, you can click on the link, and it will take you to the instructions. If you're not sure, okay? Sounds like a deal because I don't want to sit there and look at you. All I'm doing when you're doing that is watching you read. Again, hate doing that. I was patient this time because that was my problem, but now it's not gonna be a problem anymore because those instructions aren't coming up. You want them? What? I didn't, but I'm going to. The last one of these are all errors. Okay, find the error, find the error, find the error, which it's just a matter of how you say it. Whether you say it as the presenter or you say, actually looks like they're all errors. Okay, so that's quiz 7. Okay, I feel like you've seen most of the stuff. Now you have a practice. You have to practice, and quiz 7, you can finish them both next time. Hopefully you learned something. Hopefully it was helpful. I feel like also this thing that we went over had a lot of stuff from the first test, didn't it? This was like a lot of first test stuff. So I don't feel, we have that video also available. So that's good. So next time I'm going to do 3 things. I'm going to go over quiz 7. I will go over the practice test. I will also go over, I think the discussions were done. You did them already. I don't have to go over them, but I'll go over them next time. I'll do everything next time. So any deadlines, I'm gonna have to remember to change them to Thursday. No exceptions, because after Thursday, you're concentrating on what? Midterm and only the midterm. Any dates you might have, you're canceling all of them until you take that midterm. Okay, now. You can take it either day, even if you were one of those people that said, I couldn't possibly take it on Saturday. You can take it on Saturday. I don't care. I didn't keep track of who said what. Take it on Friday or take it on Saturday. Just the more of you who take it on Saturday, the longer it takes for me to grade it, because I'll grade them on Friday because I have nothing better to do. But when they all come piling in Saturday night, which they do, I will be I'll be stuck there. Okay, I have to do one thing. I have to take attendance. And how do I take attendance in mod 7? I ask these questions again. All right, if you're not here, you're going to lose points. Devon, what is calculus? Not here. Kara, what is changing in calculus? Kara. She's not answering. She's not here anymore, but she was. Should I give her a point or 2? Oh no, that means we're 2 points off. Okay, Mahir, what is a rate? That's fine, thank you. Naina, you're here. What's the relationship between position velocity and acceleration? I did not hear anything you said, but I'm sure you said what you said before. Fine. Anusha, what's the mean value theorem say?
It says that the average rate of change is equal to the instantaneous rate of change.
Beautiful, nicely said. Melanie, she was here, but I didn't hear her the whole time. I'm inclined to take the point off, but I won't. Suhave. There you go. Nyla. Sarah. Jacob. What are the critical numbers? Thank you.
X values where the derivative is 0 or undefined.
Thank you very much for participating in class today remotely. And for those of you who came, thank you for sitting so far away that I couldn't possibly get COVID from you. Have a good day. I'll see you next time. Remember, do all that stuff between now and Thursday, and then you have the test. All right. Take care. What?
What time does it?
It opens Thursday night at midnight. So that's why I have to have all my editing done Thursday night.
So it's it opens Thursday midnight and then we have until Saturday.
Midnight.
To do it.
So it's midnight to midnight, but it's 2 full days from midnight to midnight. All day Friday, all day Saturday. Friday includes 3 o'clock in the morning. If I take it 3 o'clock in the morning, go right ahead. Honor lock is there. Yes. Take care. Have a good one. Take care. Anyone at home have any questions before I shut this?